Benoit, I think that we can start, and then yeah, hoping that the others will join in. Okay, so to everyone, so thank you for attending this interim meeting. That we this is the second one, which is focused on the digital map. So the note will applies. Please make yourself familiar with the, I would say, the various disposals that are in the slides there. If you have any concern or any clarifications, feel free to contact us to the chairs if there is any required clarifications. So yeah, to just focus on why we are holding this specific interim meeting on digital map. So 3 objectives there. It's make sure that we agree on the concept definitions and the solve any issues that are related to the concept itself. Then the second one is try to consolidate a set of requirements to drive this work. And discuss their scope and I would say how they are applicable to this effort that we are doing here in this context. And the third objective that we would rightly to have more visibility on it is what are the experiments and what are the option that we have so far on the table to do the assessment. So far there are 2 approaches. So we'll hear from the working group today the more details on each of them. So to that aim, this is the agenda we are proposing for to the working today. So basically the concept discussion, then the discussion on the requirements, and then the slot for the various assessment plans, and then hopefully the more visibility on the next steps in these directions. Are there any comments or any question on the agenda so far?
And if I may add, I'm going to cut and paste the location of the meeting minutes. As always, it's a collective effort, even if Thomas, our secretary, gracefully agreed to take the lead here. So make sure your comments are well noted. Thank you.
Any other comments on the agenda? If not, we can move to the next one. So just a quick update on the document status. So far we have 5 documents, with the one about the digital map, which was accepted recently, adopted by the working group. So we'll have more details on that during the session. Also, this is the status of the current milestones. So we are closely following the milestones for the working group. So we added a new one for the digital map. So the target is to submit it to the ISG by June next year. That means that we will be targeting a work group last call on the requirements and the definition by April or May if we can. Okay, so that's all what we wanted to share with you for the introduction, and then I will now pass the floor to Olga for the first slot. So I will give it to you, Olga, and now you have the control.
Thanks, Med. Hello,
yeah, please, just before we go to the presentation from Olga, as we are not that I would say many on the conf today, so we can keep it interactive. You don't need to, I would say, to ask for the queue and so on, as far as we keep it understandable for everyone. So you can feel free to interact and to raise the question and clarification question during the sessions themselves. And the floor is yours, Olga.
Thanks, Madam. I'm presenting these things for the authors as well. Like, we had a separate meeting discussing all the comments. So these are some of the proposals we are putting. So the goal here was to discuss the issues related to the concept definition, applicability, etc., focusing on terminology and the concept itself. Thank you all for adoption and also for so many comments that we received. And I listed some people here. Pierre, we got comments from you as well, but I didn't see them on NMOP, so please send if you didn't already. There were many comments received about the term, definition, how it relates to digital twin, applicability, etc. but I think most of them were really about some confusions and how the document was not clear about the digital twin, and also saying the digital twin is just one of the use cases, and maybe the definition shouldn't be, and the concept itself shouldn't be tightly coupled with the digital twin. So we had a separate call, and I sent an email to the group with some proposals and topics that we had. And what we agreed is to propose the following first steps. So first, although there were some comments in terms of proposing different term than digital map, we couldn't agree on anything. So we are proposing to keep the digital map, but define it better and define it independent of the digital twin, because it's only one of the use cases. To update the draft to ensure that it's very clear that the digital map includes only core multi-layer topology and links to other YANG modules and data as well, because the problem was that there was misunderstanding and the document was not clear about the overall scope and what models are in, what models are out. And then after we focus initially for this interim on these two, maybe then we would continue addressing any other comments. So all the comments on the mailing list are under these 4 topics, if you want to go back to them and search, starting from when we discussed the definition of topology, then term and scope, then comments about the definition, and during the call adoption also there were some comments. We also tried, and thank you, Med, for opening some of them. Med started opening the issues here with some of the comments in mind, and I added few of them afterwards. So please, if you think that some of your comments is not properly included here, let us know, and we want to be sure that all of these issues are covering the comments that people have. Thanks, Med, for addressing issue 4, which is closed, and we can start addressing issues 2, which is the vague term, 5, which is the, again, term in relation to digital twin, and issue 7, which was open for the topology definition. So maybe I can start with that one.
So Italo, I see that you have your hand raised. Do you want to interact?
Yes. I
Feel
think
free.
I got here also, and can you hear me? Hello? Can you hear me?
Yes.
Okay, because I have a new laptop and I was checking. Okay, I think another important aspects to clarify the terminology is the relationship between digital map and
Sorry, is it
topology
just
and
me?
topology.
Is it just me, or I'm not hearing
You're not
Italo
hearing me?
properly?
You are breaking up, Italo.
Okay, is better now? Okay, 1 second.
Yeah.
Keep talking.
Okay, I'm saying that another important aspect, which is I think is key for the solution assessment, is the relationship between digital map and other topology and T-topology applications in particular. It's something different. It's a subset, it's a superset, it's an intersecting set. This is something which, when I'm reading this draft and from the draft and from the discussion, I'm very confused now. Because I thought it was a subset. I read draft and I came to the conclusion it's a superset. So I think it's important to clarify the relationship. Maybe I was thinking this morning, one thing will be to have the maybe a paragraph that describes the relationship between digital map and topology use cases. Thank you.
The goal about this was not to propose is it TE or is it RFCA 345. That's another draft, I think, but we could talk in the context of the
I'm
use
talking about in
case.
the context of use cases. Yes, exactly. What is the
Yeah,
relationship between
yeah.
the map and other use cases where you need to know topology information? Yeah,
Yeah,
not just focus on use cases. I agree.
Yeah, okay, thanks. You're breaking up a little bit, but as far as I understood, you are proposing to address some relationship in the T use case when we go. So one of the kind of comments here is, yeah, so this is maybe the comment one that you have. We can see whether it's it has to be updated with anything new, but that was the plan to address those things, but we didn't address them for today. Excuse me. So I think our discussion in the NMOP after the IETF 120 started from the terminology for topology, and thanks for all the comments inside the issue here. I tried to copy all the comments from the mailing list, and there was agreement that topology has not been defined. Somewhere there are references all around the place. There are kind of people assumed it is, but at the end it isn't. So there were some suggestions to use external Wikipedia definition, but then there were other suggestions to kind of make some basic definition ourselves, and maybe also to relate them to some other drafts, which I didn't do it at the moment. So what I did is I made some minor change and just wanted to remind you that this is how we defined it in the draft, and that we defined two terms. One was topology, and then one of the feedbacks was to explain what layer is, because it wasn't defined anywhere. So we kind of added the definition of topology layer. So these are the two definitions, and this is how we propose. This is the initial proposal for the definition. So maybe those who kind of had comments about the topology, if you could review it. I don't know if you want to discuss it now or whether to continue on the mailing list to comment on these definitions.
Yeah, just on this specific point, I remember that Adrian has raised a point on the mailing list that we should be careful on the definition of topology to not bring what is already used in other RFCs. I don't know, Adrian, if you you had time to look into I would say the current text which is proposed by I would say by Olga, and check with the ones that you have already provided in the list last month or right after the meeting, last IETF meeting.
No, sorry, I haven't done that. If you want to assign me an action, then there is a 50% chance of it being done soon.
So Olga, you know what you have to do.
If you could, Adrian, just come back with your review of this, it would be really appreciated. But we will also, I will also look at the other drafts as well. I didn't have time for this meeting. Any other comments? Danielle?
Yeah. So while I think that defining a topology layer is something extremely useful that could clarify how the different pieces are put together inside the map, I think that using the term topology is a little bit risky, because topology is something, the definition of topology is something that already exists in so many places that it's it could create confusion. So I don't have a better term in mind as of now, but topology is something just to clarify that is not just topology as we know it, but it's something different.
Just to remind you of the history of this, we didn't have topology and topology layer originally, but because RFCA 345 was talking about topology and we were discussing layers and topology and all of that, the comment was, find the definition of topology. And I tried to find it in the IETF somewhere, and I did find it on Wikipedia, but it was kind of a little bit generic. So I tried to put it in the context of the RFC 8345, you know, and then topology layer in that context. So originally it wasn't there, but because we talked about it and used RFC 8345, the comments came back. But where is the definition, you know?
Yeah, but okay. I mean, sorry I missed that previous steps, but I mean, the comment stands still. I mean, if someone is used to a definition of topology and sees here something different, it could be, I mean, creating some confusion. I'm not saying that this is not useful. Just find a different name. Topology layer, for example, is something that is perfect. I mean, that's clear and gives a clear indication of what is done there.
Okay. Okay, I'm sure that in different drafts, you know, same as inventory, someone would talk about topology and consider physical only. Someone would talk about topology, consider service only. You know, for us, when we talk about topology, we talk about both physical and logical and service.
And what about aggregated topology? I'm just shooting a name to show that is something different from what we have in mind. Aggregated topology is something that joins layer 2, layer 3, and so on. I'm not saying not to use it, just to call it slightly differently. Just a suggestion, nothing more than that.
So Benoit, as a contributor, because I'm an author of this draft. So Daniele, your point is that the topology layer is not always about topology. It could be, right? It could be a link, it could be a routing, it could be application, it could be service, it could be optical. So Olga, your point is that in this definition, it could be any of those terms. And what about this proposal that actually we don't use topology layer, but you use a digital map layer, right? Because in the end, it's like a multi-layer view in digital map. It could be optical, data link, or physical, routing, service, application, intent, you name it, right? Would that be working? Just a proposal?
For me, it would, but my concern was not with the topology inside the topology layer, was with the topology standalone, the first one, not the second one.
Oh, sorry, I misunderstood then.
So if you wanted to call it a digital map topology, I'm perfectly fine with that. That's not making me think, okay, what's the relationship between these and 8345 or the topology that I've seen in IETF in the last 20 years, something like that.
Okay, the one of the things is kind of the problem that what we saw in the last 20 years is that different functions and different layers called the topology, but they didn't define it as far as I understand. So, you know, but I do agree that having the digital map topology could be useful thing, but I would still like if you can refer me to any definition of topology, because I couldn't find it. People were just using it like it's a term accepted, you know, and so I don't know whether it's Wikipedia definition or, but this is aligned with that. I don't think this is not, this is aligned with Wikipedia definition, I think. It's just additional information. What do you guys think about using digital map topology instead of topology? Any opinions?
I've got a slightly different question for going to that one. I was just sort of going to somewhat echo Daniela's comments that I find the definition of topology here to be somewhat confusing. So the topology layer, I understand what that is. What I don't understand with topology is, does that represent the set of topology layers collectively together? Or is the definition of topology just meaning, again, one of those layers, or is it meaning something else? So I find there's two definitions between them. I'm not really understanding how the two relate. Does that make sense? So the topology layer is the topology for a given layer. Is topology itself meaning just again one of those layers, or is it, what about the collective set of topologies together or across all layers? Does that have a definition?
Yeah, we called it in the next, we said multi-layer topology, so that was not defined as a multi-layer, but definition here is as a single layer, and then multi-layer would be
Okay.
multiple layers, but we didn't do multi-layer topology. We just did a topology as a result of the comments that we had before, that the basic topology is not defined and then the topology layer is not defined. But based on what's here, it says physical or logical and how they are related and arranged, and for service between customer sites. And so it is really like for network and service topology.
Okay, then I want, then actually that's probably okay. I just wonder whether you could get away with not defining topology at all and just define topology layer, maybe. That's way out.
You see it coming in the ISG, right?
Of course. This is what doctors get stuck on. Yes, absolutely.
Yeah, there is sometimes confusion, when people are talking topology and then they just refer to physical topology, So I think there is some value, to say that there are different, the topology is either physical or logical or network or service, in that context. So I would rather have digital map topology than removing topology at this point altogether, but that's my vote.
Or another choice could be, I mean, that'd be okay, or abstract topology, some other adjective to describe it, maybe.
Yeah, maybe I need to check 8795 because maybe abstract topology is already defined there. Let me double check. I'm not sure.
I guess I can go. It's Dan Wei. It's funny because this morning, in my morning before European time, we were debating again on what is topology just before I joined this call. So inside Bell. So I know it's confusing. So maybe, Olga, I don't know if we could reverse engineer it. If you do digital map topology, what would be the requirement that you would need to actually create a digital map with topology? Because I'm coming with 20 something years of experience in MPS. It's maybe too much experience there, but it's not just like following the OSI model. No, you have different layers of topology inside MPLS. And then you have your physical topology that people would say, oh, just use LLDP or something like that. And then we're confusing where we put the real customer, the real service. So if I'm writing like a digital map topology, what do we want to represent here? And then what would be the requirement to make this representation? That could be how we start. That would be to make it practical, a little bit like what are we looking at? Because there's many ways to represent all the layers of a topology. Do we need all of them? So a definition will be helpful, but also for this work, it should be maybe start with what we need and what's the requirement to get that. That would be my 2 cents.
Maybe just from my side, real quick, I would definitely add layer and keep topology and network topology as a definition. I think if you go towards digital map, we again open like yet another door, because digital map has different meanings, I think, in different contexts.
Yeah. Okay, so we started the new discussion about, so Matt, because we had 20 minutes, should we continue doing discussion on the mailing list, or?
Yeah, for this point, I think, yeah, we can have a dedicated thread on the actual need to have a formal definition of the topology, and we can separate it also by the need for it, and then the content we would like to associate with it. So we can have this discussion open there. But as I discussed with Benoit, we can have 5 minutes more for this presentation, so that you can move to the other points you have in your presentation.
Okay, thanks. Thank you. So the first thing was about topology. The next thing was about the digital map. So these are the two issues. I won't go to them. There were different topics on the mailing list. Summary, as I mentioned, keep the term decouple from digital twin, qualify better. And we updated this in the draft. And we removed digital twin definitions. So this is really the terminology part of the draft. Digital twin was removed. Digital map definition was updated, and the reference to digital twin architecture was removed, so that there is no reference to that one, because that was also one of the comments, because it's NMRG and this is IETF. Should it go that way? So the current proposal is the digital map is a basis for operator network and service models that provides topological information of the network. It provides the core multi-layer topology and how to connect them to the other models / data. So I'm sure topological information of the network and services probably is missing if somebody assumes that network is not network services. For me, I think we defined it in the other terminology as a network that includes both services and network. So this did address the comments originally, but maybe this can be improved further. So I don't know. I did share this with those who had who I got feedback from prior to this meeting. So I don't know if anyone wants to give their opinion or further feedback.
Yes, could feedback be trying to help here? The last two comments in the chat here, my understanding is what you're trying to define in terms of topology in general. If we had an IETF official document on what topology is, then when it comes to digital map, you do it like a la carte. You grab section from that official document of topology to plant it in your document. That's how I would see it. No? Oh, wrong meeting.
So trying to understand, then you are in favor to try to have a topology and digital map terms here? Sorry, maybe I misunderstood your
No,
statement.
it's essential to have topology in digital map. What we are confused right now is what's the definition of topology, right? So maybe that's a work that should be done before, and then we grab the block from what we need to create digital map after. That's just my 2 cents here. I think it's obvious that we're lacking of a official document of what is network topology. So do we define it here in digital map, or should we define this before? That's maybe the question.
Yeah, I think then we for the last point that we discussed, we see that we will bring that point discussion to the mailing list to see whether we need that term and what definition we can put against that term. And so the discussion will be happening on the mailing list. I think Olga is seeking for comments for digital map definition itself here. And my feeling is that there is no comments for this one, Olga, and we can move for the next one. So then we can keep that discussion on the mailing list, please, on the definition itself.
Excellent. Thanks, Matt. Thanks. So these are the other terminology for digital map. There was a requirement before to add digital map modeling, digital map model, and digital map data. So these three are also defined in the context, and the definition for digital twin, we removed it. So please review these comments in the context of the digital map. So the abstract has been changed. This is the diff for the abstract. You can go to the GitHub and see the latest pull request. So we are defining it, removing the digital twin from this part. For introduction as well, there was a big introduction before, which had a discussion about digital twin, positioning with digital twin. So we just reduced it to contain the digital map concepts. So this is addressing the digital twin, tightly coupling, and NMOP versus IETF comments. So if there are any comments, please let me know. And then for the use cases as well, our original sample digital twin use cases, it's removed, and we added digital twin just as one of the use cases, and some text was changed. So this is the minor change for the use cases. And for the use cases, Pierre's comment here is that the proposed definition of the digital map is restricted to the topological properties of the network. And he said, I'm not sure your listed use case can work with only topological properties. I agree completely with you, they can't, but they all need topological properties and topologies, so each use case would then have additional models and additional data that it would need for that specific use case. But each use case does need a topology and relationships to other data, So the goal here is not to model everything. The digital map is not the full model of all data, that it's just topological model, multi-layered topological model from bottom to the top with links to the other models, so that the applications can be driven by topology and then get access to any data that they are interested in, So if I'm interested in saying, I will go to the symptoms. If I'm interested in configuration, I would go to configuration, but I don't have to understand everything, all data. I only want to understand topology, and topology is shared. That's my opinion. I don't know if others agree. Thanks, Pierre.
Yeah, Olga, please, if you can wrap up for this slot, please.
Okay, thanks. Adrian also has a comment, so I'm just, if you can copy it and save it, that we don't lose it, please. So these are some of the next steps and open questions. If we can agree on the proposed terms and discuss them in way, we can move it to the mailing list and then integrate the PR when we agree. Discuss requirements. I have separate presentation. We want to close these open issues, update to draft to ensure all the scope concerns are addressed and intended use is clearly described, and then submit a new version prior to IETF 121. And open questions is one of the things there in the comments, in the issues, is add more description for each use case. But I'm just wondering here, what is the goal? Do we just want to add a description, or maybe the more valuable thing would be to add how potentially digital map could be used for each of the use cases? And I don't know if there's anything else that you guys want to suggest as next steps or open questions. Okay, thank you. So this one is about the requirements, and the goal is the detailed presentation and discussion about each requirement with a goal to agree on the stable set of requirements, consolidate them, agree, avoid biased one, etc. So the goal is then that this work can be stable base for further analysis of the approaches and the models, etc. So I didn't do any updates based on the requirements in the original document, and we didn't really have, as authors, discussion after the last review about the requirements themselves. But these are the current requirements that we have. And the first thing is that they were split into categories, and the history for these categories was that the core requirements were really something that we kind of did through the POC and validated with the operators, and the operators gave the feedback for those requirements. Design requirements were some which were kind of added during the POCs and hackathons as something that was considered important for the design of this API, and the architectural requirements were really the ones that were just added as a kind of non-functional one for scale, and then important one for the content of the digital map data, whether it contains for up-to-date, for real-time information, that it doesn't, having polling is not sufficient, that we do need to have initial information, and then that all changes have to be reflected. So these are the kind of categories. I'm not sure whether it makes sense to keep these categories going forward, but I just explained the reason for having these categories. So I see there is a lot of discussion on the chat. I'm missing it. so shall I?
This is actually for the topology definition. So
Yeah.
this is what Matt mentioned is going to be discussed on the mailing list.
Okay. So do we want to proceed with the chat about topology, or should we proceed with requirements?
No, please proceed with the requirements, please.
Thanks. Thank you. So the first core requirement was the basic model. So it was, we have lots of them, so I don't know in terms of time, there are 40 minutes left. So if you don't get to the end, maybe the reviews and discussions could continue on the mailing list. So the first one is that we need basic model with network, node, link, and interface entity types. This means that the user of digital map must be able to understand topology model at any layer via these core concepts only, without having to go to the details of the specific augmentations to understand the topology. So this was for the core model, requirement for the core model, that we can have a topology defined through network, node, link, and interface types and relationships between them. So this is the RFC 8345, and where they described that the purpose of this RFC is to serve as a model for any layer, for any network type, for any type of node, for any type of termination point, for any type of connectivity or link, so that you can have topology graph from that. So that was the purpose of the 8345, and then augmentation can add non-topological information that is maybe specifically required for that specific function, but the problem here is with all these augmentation is that some of these augmentation add their own topological concepts, and then if I'm the user and if I want to understand topology, I would have to go to all of these augmentations. So this requirement says, okay, I need some basic model that if I just know the basic model, I could still understand topology without having to go into all the augmentation. And there was also discussion. Yeah.
Is the network topology not considered an augmentation or not? Because network topology is an augmentation of the network.
Yeah, network topology is the, sorry, when we are talking about the core model, it's network topology, not network. Here it's network topology, here it's network. When I'm talking about augmentation, I'm talking about all the other ones that are augmenting it for different functions and different technologies. So this would be the core model that we started
here
from.
we need more discussion. I think it's a bit an artificial element, because I remember, and I was at the beginning of my work, I was not involved, but I remember that the authors of 8795 and the authors of 8345 and an intensive discussion about what should have been 8345 and what should have been 8795. But
Yeah.
I don't remember the idea was that 8795 is not part of the core for a technology agnostic, because 8795 is also intended to be technology agnostic. So I think we need to be very careful about here where we speak about not specific augmentation. Yeah, I'm not sure that that was exactly the intent at that time.
The intent, you mean between why the network and network topology is separate? Or are you talking about T?
Topology. T and network. There was a long discussion.
Oh,
I'm
yeah.
aware of it, but I'm not aware about
We could
what they
ask
said
Alex,
and why they keep the
actually.
car split. Yes.
Yeah,
Yes. I don't.
they split it in the
I
document. They are
came
saying the reason why they split it is because they understand that some may not be interested in topology and they may
network
only be
topology.
interested.
Olga, I'm talking about network topology and T topology. So the authors of 8345 and the authors of 8795 had a long discussion about how to split between the network topology and the T topology. I was not part of the discussion, so I came after the fact. So I don't know what was there. I don't know if there are any of those authors on the call, but we can check offline why they came with a current split, because
the split, and historically I thought that this is done before T topology and that T topology was
No, it was done at the same time.
At the same
split
time.
was agreed at that time. Yes, I'm pretty sure about that. But I was at the end of the discussion, so I don't know exactly why they decided to split in the way it is currently the split. So we can check with them.
Yeah, like to me, it's kind of obvious because you want to have augmentations for non-traffic engineering, that it's simple for, and that's why we have all these augmentations which are using network topology. Otherwise, it would be much more the T is, as we know, a great model for with all the information that you need for the traffic engineering, everything. So it's very good model, but it's very complex model. But I was not aware of that because I thought as a kind of core model
have you noted
that it was introduced
a
on
lot
its
of
own.
augmentation has put the same attribute multiple times. So that was too simplistic at the end.
Yeah.
So
when I read RFCA 345, the intention really was as probably very similar to what we are trying to do now with the digital map, but without links to other to other models, is to provide a basic core model of topology that you can present any topology as a simple graph, because any topology is a simple graph. So by just understanding these kind of four concepts, that you can build your graph of any topology and any layer at any technology or anything. I think that was the purpose of the RFCA 345, and then to provide a multi-layering.
You discover that there is a gap when you have a multi-layer, that you don't have the interlayer associations, which are missing from 8345. And the reason why the interlayer association has been put into 8795 is something obscure to me. So that's why I'm saying I don't know why they made the decision the way they did.
Sorry, when you say interlayer, You mean
client server layer?
between
Yes.
the layers or inside the layers?
Between the layers.
Partitioning?
Between the layers. Between the layers.
Okay,
There is
they
a point where you
they
from
define
the
they
client layer
find
to the server layer.
they define the relationship, supporting relationship, as an underlay overlay relationship. That's what how they define
But that
it
was
in
not
RFC.
that dimension lag, which is not that is not a multi-layer. It's an aggregation. So it's
How do you mean?
I don't see if I see 8345 and I think you came to the same conclusion as me. I don't see how to create a multi-layer topology.
Yeah,
from
no,
8345
multi-layer.
alone.
So they have
So
layering, they don't have partitioning, and that's very unusual. So they could support
yeah.
layer
But there
and
was a
dependencies,
key,
but not partitioning. Yeah.
but there was a key requirement at that time, and it was put under 8795. And I don't know why that was the design choice made at that time. Because if I follow what you say, then I would say why it's not in 8345. That's exactly the point. And I was not there, and I cannot say why, but the reality is that with 8345 you cannot model a multi-layer topology, and that was well known at that time, because multi-layer topology was already a well-known requirement when 8345 was approved.
No, they claim it's they support multi-layer topology, but then they don't support multi-domain. So one thing is a multi-network, multi-domain partitioning. Another one is multi-layer. So their claim is they support multi-layer.
Both
but they
multi-domain
don't
and
support
multi-layer was part of it, but I don't see any multi-layer because I don't see how you have the layer transition.
Okay. Okay, in the POC, we were able to do multi-layer in terms of the modeling, basic modeling and basic relationship between different layers. What one of the gaps that we identified exactly was that here you can have different networks, but you don't have relationship between networks. So I think there should be a possibility to have a sorry, there is supporting relationship, but there isn't a kind of partitioning capability. So, we could do it through supporting, but it's really not supporting. It's more like a hack. Ideally, you should be able to have a hierarchical domains as well. Okay, so this is the first core requirement. And from the POC, we were able to do all of this. We were able, with links, to model tunnels, paths, anything that is on the graph connecting two nodes. We had a node with interface, which was, and then links connecting those interfaces, a network like being a container for one layer. So using this concept, as you know, we were able at the time to model all the different layers, but of course we didn't do the use cases for those layers. We just did the modeling of those layers. So that's the first requirement. The second requirement is the layered from physical up to service application. We say here service and intent views, but it should really go to the not just the service and intent, topological intent, but to the application as well. So RFC 345 also talks about supporting all the different layers, that each layer could be modeled using the same concepts, and then that it can be done in a very generic way, that we don't have to have that application doesn't have to understand for each of these different layers some kind of different concepts. So this is example then of how we can use these concepts for layer 2 routing and VPNs, for example, and this is from our POC examples for multiple layers. So any questions about this one? Okay. So the third one was...
Olga, can you go back to the previous slide?
Yeah.
Yeah. Okay. Now I can understand what you say here up to a certain point. that you can have, well, I still don't understand now, because how do you know the path? If you look at the VPN, at the link between VPN node A1 and A2, how do you know the path, the underlay path for that link? I know that this part, the VPN node A corresponds to node 4 and VPN node 2 corresponds to node 2, but I have no way to understand that there is a path in the routing network between node 4 and node 2.
Italo, you are breaking again. Sorry for.
Okay. Yeah.
Is it just me or Ahmed? Can you hear
Yeah.
Italo?
No, it's my VPN.
Yeah, it breaks on my side as well. But I just wanted to make one, I would say, comment here about the discussion. We need to avoid, I would say, having discussion on the base topology specification itself. We need to focus more on the content of the requirement itself, independent whether how this is realized by the existing models themselves. So please focus on the clarity of the requirements, whether the requirement makes sense, and whether we agree on that content as well. How this is actually implemented, it doesn't matter at this stage.
Okay.
Yeah. Okay, but okay. So can you? Is better now my voice?
Yes, yeah, much better.
Okay.
Yeah.
Okay, I think one requirement. Okay, yeah, okay. Thank you, Matt, for clarification. But one requirement here is, for example, the link between VPN node A1 and A2. We need to know what is the path in the underlay network which is supporting the link. If you really want to have a multi-layer visualization of your network, because knowing that there is a link between the two nodes, and knowing that A1 corresponds to node 4 in the routing network and node A2 corresponds to node 2 in the routing network still doesn't help to correlate exactly the multi-layer view, because you don't know, for example, in the what if analysis, you don't know whether a break on the link between node 5 and node 2 is affected or not the VPN-A, because you don't know whether on that link the VPN-A traffic is over or not, because
so parts would be underlay. Yeah, parts would be
the underlay path is
of
not.
course, yeah.
Okay, yeah, that's an important. I think it's better to clarify that is also an important aspect of the multi-layer correlation.
Yeah, definitely the parts. This is just saying layering, but it includes anything you need from physical.
That's why I'm saying, yeah, exactly. That's back to what my comment before. Yes, that's an important requirement in multi-layer.
Yeah. In some cases, the only when we were discussing with the operators and all of that, because of the dynamic nature of some of the parts, we were saying, okay, some dynamic parts may be external, and then they could be retrieved because they are quite dynamic. So there was a discussion whether they are the core part of the digital map or whether you can have them in traffic engineering and retrieve them or something like that. But in terms of modeling, I think parts could be modeled using the four concepts as a kind of links on top of the links. But the issue is in terms of the implementation, because of dynamism there, whether they can be always there on demand, or there are some performance or scalability issues maybe when implementing this in the controller in regards to the parts.
Yeah, Thomas here. Just one question, and I did not quite understood what Italo was mentioning before. He remarked that basically, if we know the VPN topology, that we should also know in the underlay the physical, let's say, topology where at the end the packets are being forwarded. Did I understood that correctly, Italo?
Operators who wants to know which VPN traffic goes over which fiber, and if you don't have the relationship between the link in the client layer and the path in the server layer, you will never be able to go down to the exact VPNs, which will be traffic which goes over a given fiber.
Right. Here I disagree, Italo. The thing is, if we want to achieve that, we would also need to understand the ECMP hashing of the network device, and this is not part of the topology itself. So this cannot be achieved.
Yeah, what we did in the POC, we had the capability to do the things for the tunnels and for SRV 6 policies and model them that way, you know. But as Thomas was saying, if it is something more dynamic.
Yeah, okay. Okay, I will take this note and we'll go to the operators. I will not be able to meet your requirement. Okay, thank you.
Thanks. Can I move on? So this is the requirement about open programmable digital map. So we discussed having the read operations and to retrieve the view of the network. And this is for controllers and orchestrators to understand the topologies and how the things relate. But it also includes write operations, which we're talking about the offline simulations and what if scenarios. And running a what if requires ability to take snapshots to switch easily between them. There were some comments from Pierre and Vivek around this one in terms of how that can be achieved. And they asked us, so I put these two things as a reply to Vivek and Pierre in terms of like, this is just my opinion, so please don't, it's maybe there are other options, but I was thinking, yeah, you can have different snapshots. It could be the unified API, or it can be the same model, but different endpoints where the different snapshots would be existing in different instances of the implementation. So you can have a different endpoints, or you can have, in this case, if it's a single API, I don't know, maybe something like young data stores could be used for different snapshots. And in this case, you know, it can be explicit that the one would be used for this purpose versus another. But in general, the requirement, it's not how the requirement is that it should provide both read and write capabilities.
How can you match the what if analysis if you don't know where the traffic is?
I don't think applications would just need this part, you know, again,
But,
this is the core model.
yeah, but if the link breaks, you don't know who is going to be affected by the failure of the link.
Yeah, I think what if would
So,
have to contain both real time but then application could go between the two. So
I'm confused. If you don't know what traffic goes over a given link, how can you do the what if analysis on the simple what if the link fails?
the analysis is not part of the digital map. Analysis is done by application on top of the digital map.
But how can any application that it perform a what if analysis can assess what happens on the link without knowing who is using the link? It could be that there is no traffic on the link at all, so the link failure has zero impact on your network. Everything works perfectly. Or can be that very high priority, very high sensitive traffic is going over the link, and it may be a disaster if the link fails. How do you know that?
I'm sure that application will have to retrieve other sources information about the traffic of the link or anything. This is just part of the core model, core digital map.
So it actually depends, because now we're getting into specific of use cases. You have one use case in mind, but you know, a simple capacity planning and what if on the capacity planning network wide is also interesting. I need to have so much traffic from this entry point of my core to that exit point of my core, per QoS, right? And even if there is ECMP in there, this is the total of all of these. So you have one specific use case, which is like more like the service or the application assurance aspect, but there are multiple ones.
I don't disagree. I just say that in all of this, you need to know how the server layer path correlates. Yeah,
no, I just proved that for the specific use case I mentioned, you don't need that.
Well, if you need to do capacity planning, at the end of the day, you need to know which fibers you want to lay down if there is not enough fiber capacity. And again, it depends on where the traffic goes. Because if the traffic spread over can equally load the two 10 gigabit links and you have two 10 gigabit links in your network, you have enough capacity. If there, for any reason you are not able to load or equally load the two links, you may need to, for example, upgrade one of the two links from 10 to 100. And without knowing, again, how do you send the traffic through the network, I hardly understand how you can know whether your capacity is good or not.
I would suggest, in general, if multipathing is being used, basically all the involved links, it's part of a group, and we cannot distinguish basically which flow is over which link. So we can assume that these links are within that group redundant.
Okay, that means that you need to say this link is supported by a set of parallel paths where the traffic is low balanced.
Yeah, that's
That's
the
good.
yeah.
Yeah, that's good. Yeah, that's that. But then again, that's back to that's an improved requirement, but there is still a need to understand the relationship between the link in the client and the path in the server. It may not be as simple as a single path, maybe multiple paths with some ECMP load balancing among them. Then on that I agree.
Yeah, I think from the perspective of the graph and how you see topology in the graph, you know, the path as a combination of links exists at the different layers as a link, you know. But then through the relationship of different layers, it becomes obvious which underlay links are used for that. So that's a kind of co-layering between anything, and it's sometimes between layers which match OSI, and sometimes between link aggregation, for example, or any other kind of support of multiple underlays. So the next requirement is really that we need a standard API for multi-vendor support. So that's hopefully very understandable requirement. The only thing that I put here is really a standard API for what, you know, because standard API is to provide read write for queries and capability links to external models, but also we identify some gaps that were not there in the core models. So, you know, really this standard API should be able to have A345 as we have it now, plus these gaps, not more than these gaps, just these gaps, and then how to connect to other modules. So some modules, they already augment RFC A345, like inventory, and then just add inventory information. So that's one way of how to do this link. You know, another way, if those modules do not augment, then what we need is to have some other mechanism to link, to provide probably some new young module to be used for linking from digital map to some other young modules, IETF young modules. Is this clear? Any questions? Okay. The next requirement was about cross-domain common API, because there are requirements like, you know, if you have different types of controllers, then cross-domain controller, that you would want to have the same API to support topological information and links to external worlds. So this is kind of the approach that is required. So this means that clients of the digital map API must be able to understand the topology model of layers of any domain without having to understand the details of any technologies and domains. So this was the original intent of the RFC 345 in any case. The only problem is that because they don't support multi-domain, the cross-domain approach would be difficult because you wouldn't have network that contains networks. Although they did say you could do it through the, I think, virtual node or something. Hi, Dan.
Hey, Olga. Sorry, this snappy question here. What do you mean by domain here? Is it like 3 different IP domain, or is it like access, metro, and core domain? Or is it
Here we have example, access, campus, core, but it could be, data center, and in some cases it could be also depending whatever is the domain for the operator. In some cases, I know that operator would even have a domain per vendor or something. So, but in general,
it's an IP domain. These are all IP domains. We're not mixing like optical transport as domain.
I would say this is kind of examples of the access and core, and then but the campus and data center. But I think optical would be a layer inside the domain. Is it?
Yes, in the core network. Yes, maybe not in a data center. It's mostly point to point.
So in some cases, the optical would be underlay layer of the domain.
Okay.
Thanks, Dan.
So maybe if there's a draft, maybe we should specify that or reference it to other work where we talk about domain, the notion of domain. Because you're not saying multi-layer here, we're saying almost like multi-domain, cross multi-domain,
Yeah, like for the layering, it was the different requirement. So for the layering, this was kind of layering requirement. And this one is for the domains, and specifically because RFC 345 has limitation here. So that the reason why this was added is because there were requirements to have operators do want the same APIs for different controllers in different domains. And also there was a requirement for cross-domain. So this is one of the gaps that we identified in the RFC 345.
I have the same thought then about what's the meaning of domain, and I understood now from the conversation this is basically administratively defined. So this is not coming from the network itself, how it's being configured. This is how an operator divides responsibility. And if that's the case, maybe we could take as input the so-called open digital architecture from TM Forum, because there you do also define a decoupling into different areas. So maybe this goes into that direction.
Yeah, there is. Yeah, you're right. It's originally in ITUT it was administrative domains. Yeah, so
exactly.
Yeah. Thanks. So this one, I think this one is very important because you know the RFC 345 supports very partial semantics that is needed for the layered network topologies, and there is nothing for linking external models. So we do have layering and types. We have nodes, TPs, links inside the network. We have what nodes and links are contained inside the network, what TPs are contained. We do have some relationship in terms of very simple one without properties, without anything. Then again, what is the path? Can be a relationship between end-to-end paths and low-level links. Domains and subdomains, that's where things are missing, but I won't be talking about what's in RFC 8345. These are the kind of core topological requirements. Then, some roles in the topology like primary, backup, load sharing, hub spoke, unidirectional, bidirectional, it doesn't support bidirectional. And then the semantics that really is used, how to build the layering and topological relationship, like semantics that you need for path computation and all of that. It doesn't have to be in the digital map. It can be implemented in the controller or in some other modules, and will be in the knowledge graph longer term. So here relationship is really more about A to B instance and not with the kind of some semantics in terms, how it can be built. So we are just talking here about the basic semantics to be able to understand the relationships and not to build them. So I'm sure that something is missing here from the semantics, but if you can think of anything core, we really want just to identify the core things that are needed for the digital map topology model, that are needed for all of the applications and for all of the use cases. Okay. So then this is about the relationships between the layer, inside layer. So this is layer navigation requirement. And it says digital map must provide intra-layer, inter-layer relationships. And these are the kind of ones that RFC 8345 already supports. Between the layers, this is what's there, but we did find some gaps in terms of both what's missing, but also additional semantics for relationships. And this is just the status of the RFC 345. It's not proposal that this is how enough. It's just kind of to give indication of what it means for intralayer and interlayer. Then one of the requirements was that a digital map must be extensible with metadata. So, some of the things could be done through extensibility with metadata without changing even the core. And I don't know, this is, I think, Benoit, if my memory serves me right, this is one of the requirements that we got from, so I don't know, is it related maybe to RFC 7952 and how that deals with young metadata, or is it the requirement that even without young approach that we should be able to add additional metadata, that any additional labels, additional metadata that you could add. So this was added, I think it was from the operators at the time as a core requirement. This was not something that came from the POC or from the
So since you asked me, again, as a contributor, this is a requirement that came that actually, even if we speak about an API and therefore a Yang module for digital map, we have to understand that not everything in the world is about Yang, right? So if you want to say, let me link to all the flow, the IPFix flow record I see on that interface in that direction, well, it might be required to add a way to have a label or metadata to say this is the link to the IPFix flow record.
Okay.
Right. So is this a requirement that we want to do now in the digital map, or is this something we could be doing in Yang to be discussed?
Okay. Thanks, Benoit. So the next one, yeah, so they maybe revisit this pluggable one, because here we are also saying that we also added the text, not all involved components can be available. So this may need to be changed. If we considered metadata to be non-young, then we can change this pluggable to be only young. with other model. Okay, so this is then required that we should modify it and move it to metadata. Okay, so this is the core requirement.
Olga, I think instead of pluggable, we say that they should interact with other models. Yeah, and we'll make it more generic.
Yeah. Okay, change the name of the requirement to be connect to other models, is it? Link
Correct.
to other models.
Correct. Yes.
Okay. Thanks. Yeah. Yeah. Okay, so we'll use this one as the requirement just for young, and then for metadata we would. I was thinking maybe so that there is potentially need to add some metadata that we don't know in advance, but okay, we can discuss that some other time. So this is the core for the scope really, because we have a digital map, we have a core topology model. A lot of people were saying why, you know, why do we call it digital map and not topology? Because first it's a multi-layer topology and multi-domain topology, and then another thing is that we need a connection to other young modules. And okay, for the case when the augmentation is used, then we are not adding any other mechanism. But I believe there are many cases where you have other models like in configuration, etc. And it's very difficult to connect, you know, assurance and configuration and things like that. So if we do have a capability to link topology with all these different modules, it would be very beneficial. So for that link, you know, if it's not through Ivy, like through, augmentation, like Ivy has it, what we need to do is in the, let's say in ISIS area, we have a topology with network ID, and then in some other module we have process and properties and things like that. So how to connect these things? So first thing is, you know, what server, if it is not the same API, if it's not controller, if you have to go to the device. Another one, what young path, and what category also we could say, is it configuration, is it metrics, or we can leave category completely open, and what instance, because keys IDs don't match. So this is something that for hackathon I think we were planning to do, so I'll leave that for the later, how maybe something can be proposed and implemented for the hackathon to show how some of these things could be connected. This is the requirement, I think, coming from the operator. That one of the comments that we got from one of the operators and is that by having this kind of model, it's very difficult to traverse the graph and paths using this model. So, you know, could we also optimize this model that we have direct relations from the node to the node, you know, with information about source and termination and link. So this is something that could be achieved going forward by just adding the relationship, or potentially this is something that is more about how it's stored. So maybe it's not even the API issue. So maybe we can discuss again this requirement and see if operator needs graph traversal via APIs, or would the operators retrieve things, store it in their own graph storage, and then do the traversal there? So that's something maybe we need further clarification for this requirement. If this requirement stands, then I think we would need to add additional relationship to the API that could simplify this graph traversal. Any comments? So again, this is about the scope, and this was saying only topological, but not meaning just topology. It says only topological, meaning I don't want to contain all the other configuration, you know, traffic engineering, assurance, metrics, performance, you know. it's not required to contain all models and data. It's just to support adequate pointers to other functional data and models. So this is now, I made this picture maybe to make the scope clear. This is the core topology. This is some pointers, either through augmentation or via some young module, and all the other models and data. And why I'm using terms models and data. Models are the young models. Data is the runtime API and JSON or XML that we receive. So I don't know if there are any questions about the scope and if all data is part of the digital map. I hope this clarifies this requirement. So then it was about what properties or attributes, or I don't know, should be in the digital map. And this was added more like a design requirements. This was not something that came from the originally from the it came more from the implementation itself, not so much from the operators, because the core thing was to have the properties that identify the different layers, roles, topological information, but not to have external things. So these are some recommendations maybe for augmentations if you think what's inside digital map and what's outside. So for example, in ICE's augmentation, I would consider potentially process ID, area ID to be the important things for the digital map inside, and everything else, and the configuration, status, metrics, timers, notifications are kind of external to the digital map. But that's kind of, this example is, I gave it, so I didn't kind of review it with Oscar, and so maybe this is just my opinion. So this would again clarify the scope, what is inside digital map versus outside digital map. I'm not sure, like now when I went through these slides, this looks like replica, the duplicate requirement. Because the first requirement is we need topological relationship, and this one is saying only topological relationships should be. So this requirement is more like saying, service to template, configuration to profile, service to customer, other relationships are not part of the digital map. So the first requirement is I need internal and layering, and this requirement says I don't need others. But I'm not sure if maybe we can merge these two, or and especially because it doesn't mention relationship to external models. This could be confusing, that it's just topology. So maybe this we can phrase better or reorganize. So this is from the operator capability for conditional retrieval of parts of digital map. So these are some examples based on the POCO for layer 2 and ISIS scope that was given. So this comes from the operator for conditional retrieval. This one is geospatial and history. So currently for the location, Ivy has kind of geolocation there, and it's using the whatever RFC. Sorry, I would have to make it bigger. I can't read the RFC number. 9179 is it for the geospecs. So the location is currently in the Ivy, in the inventory. For temporal and historical, there were requirements, get me current, but also operator had requirements, get me historical topologies, get me. So in that case, we do need kind of timestamp for each snapshot and historical snapshots as well. So then we had 2 sentences, but I think these 2 sentences probably added by different authors. First one is must support this, and the second one is can be supported external to the digital map, or maybe it was edited by same author at different time. So now when I read it, it's maybe a little bit confusing, so maybe we could improve it. And then these are some non-functional one, which I don't know if we want to keep here. This is most for the controller architecture requirements. So maybe this is not even relevant for the API. These are not API requirements. Except usability. This usability part is it's usability, that it's simple to understand the API, and that ease of integration is really usability. So ease of integration is give me your young module, give me your protocol description, how do I integrate? And application developers would, say, okay, I'm doing RESTconf on netconf, and then give me the standard young file, which I need to integrate with or to implement, or how to do it. So this should be the simple, and out of this one requirement is that this model has to be as simple as possible. And the application developer should not have to understand all augmentations to retrieve the core model. And this is maybe something that shouldn't go into the draft, because it assumes, this is only my opinion, RFC 8345 should be enough to understand topology. So this shouldn't be in this draft, because we shouldn't be mentioning RFC 8345 here. It should just say simple model. And this is also architectural requirement for the controller, so maybe we can decide to keep it or not to keep it. So these are the next steps quickly: to continue discussions, get agreement, submit new version. Also, there are some gaps that we identified during POC, and maybe we should add them as specific requirements on top of the existing ones. And these are the gaps that I think missing semantic, we already have that one, but and missing supporting relation may be part of the missing semantics, but maybe some things like bidirectional, multi-point, cross-domain, the petitioning, maybe they could be separate additional requirements. And are there any other requirements missing? Okay. Sorry, I took a little bit longer than planned, Matt.
Sorry, Olga, can you hear me?
Yeah.
Yeah, one suggestion. I sometimes get confused, but I think it's just your thinking. You are using sometimes the term gap and sometimes the term requirement. I think the draft should focus on requirement, not on gap. Am I right?
Yeah. But so that's why these gaps are not in the requirements.
Requirements you want to put more emphasis. Yeah, okay, that's fine.
Yeah.
Okay.
Yeah, but what I was saying, we identify these things as gaps and we communicated them as gaps. But if others agree, we could move them to the requirements as well.
Yes,
not as gaps.
Should be requirements to be addressed by any solution. Then we will do the assessment of the solutions to see the gaps, where they are the gaps. Okay, makes sense.
Yeah. Okay. But they are not requirements at the moment. They're in the other draft, which talks about our experiences in the POC. So we didn't put them into requirements specifically. Thanks.
Yeah, thank you, Olga. Unless there is any further question to you, we can move to the next slide. I think Sharif is presenting.
Yeah, can you hear me?
Yeah. Yes.
Can you hear me?
You should have the control right now.
Yeah, I have it. Yeah. So hello everyone. So this is would be a short presentation. So try to make it useful as I can, and you can ask questions at any time. So this is the one basically sharing the. So in this presentation we are sharing the code. So we have shared the code here in public, and this is the link. So basically here we're trying to show how do we use the Yang models, the IETF, the RFC 8345 with some of its augmentations as a real implementation, basically here in a real network. And this is like here we're sharing the code, and we're on the next slides I'll be showing what are the building blocks for this code, or basically the parts that you need to know to use the code. Basically what do you need to start for developing, and the output. So the output of this code, what's like the output of this code, and how can you use it. Okay, so feel free to interrupt me if you have any questions. Now in this link, like in the README file for the code, I have it's big summary. It has it's more like detailed version of what I have here in the presentation. Here in the presentation, I'm focusing on how to use this one and the important pieces that you need to understand for easy development, to start on a quick way for development. So what we did in the book that we shared. So this is basically these are the building components in the configuration files. If we go a little bit before this, so what happens is we have the configuration files, which is on the top left here, and basically this gives the structure or what's the procedure we want to have in the book or in the demo here. So for example, you can say these are the devices in my network, and you give the credentials for them. So this would be the device config one. Now, because we store the output relations and entities at the ends and instance data in Neo4j, so in the DB you give some information about the Neo4j IP port, etc. And the important ones are as well the DM scenario and netconf scenario. In the netconf, you instruct because, for example, you are trying to figure out what are the information I want to extract from devices. So you have two options: either connecting to devices and retrieving. You can choose if you want to retrieve the running, any Yang models that you want to retrieve the instance data for them. So you can choose whatever information you want. Or the other option is you already did this and you have this data. You did this one time and you already have the data. So this is all can be controlled there. So these are all the knobs basically that you can do to choose whether I want to collect now, whether I need to use the files that I already extracted before. So this is the config part. Now, the rest of the thing is more, I'll describe it in brief before I go in details, but the rest of the parts are more on how to use this data that we retrieve from the network, and how do we use the Yang models, that there are so many Yang models augmenting the digital map one. In this one, for example, I'm only focusing on some of them. So here we did the layer 2, the ISIS, plus of course the base ones, and the unicast. So we did the layer 2, layer 3 unicast and ISIS in this example. There are so many others, so I hope that things are easy enough for anyone who wants to check the code and try to do implementation for any other Yang module as well. So what you see here is, So I described the config part. What you see in the inheritance here is basically the yellow ones are kind of the interfaces or the base models, which are more like the Yang, mapping Yang to JSON files, basically. So what you see in the IETF network, this is the network and node. Under the IETF network topology, you see the TP and the link. So these are more like copied from the Yang files. So this is the same properties that you see in the Yang files. The layer 2 network is the same. The layer 3 unicast is the same, and ISIS layer 3 network is the same. So each one is basically a mapping to each mapped Yang file. Now the green one on the left is more like the implementation one. So in the next slide, we'll see more like in details how this looks like. But what you need to know now is the green one is kind of the implementation one. So you can use the yellow one plus any other attributes if you want.
Can I just, oh, sorry. Can I just add one comment for the green and yellow? Because this implementation is the kind of more like an internal model needed to build it. And the yellow one is what would be exposed through the API.
Yeah, so yellow is basically like the interfaces, yeah. So on the right here, if we look a little bit on the right, so knowledge has the important part of the knowledge or the mapping and the relations. So mapping is basically the point where you have the models, the yellow and green parts, and where you have the data coming from the collection, or you have already the folder with all of this configuration there. So basically, this is the piece that you take this information, you take the model, you take the data, and then you fit them together. And this is where there's a bit of logic there. How to create the network IDs, how to create the node IDs, more like, from where basically to extract this information. So if you look at for example, I put one example here, which is ISIS area on the left, on the right, and there is another one that's on the left as well with this dashed line. So this one is basically a Python file that you put the mapping in. So what happens here is you take the model, the data, and then you have some logic to extract or generate the entities at the end. The relations is the one that you have entities, and then you define how do you want to connect together. Basically, the rules of connecting them together. We will see this in the next slides. Entities. So imagine if you have some available data is already available. And so if you have something that is, if you have a network name that you wanted to put without extracting this from the network, you can just put this as kind of direct instance data. So this is a more detailed each file in the configuration. So you see on the left, I tried to put them as step 1, 2, 3, 4. They are kind of, it can be parallel, it doesn't matter. But basically you define the Neo4j port information. You define that. So this is the one that you see on the left, the bottom left. This is the devices. So you put all of the devices there. And it's important to categorize this per, if you have software versions, it's important to put this to be able to differentiate this, because sometimes the modules and the configuration is different across different families. So this is quite important. Now in the middle, you see the netconf scenarios, and this will actually say, okay, what I need to extract from the devices. So for each device, this all list is executed. So for example, you can get the running config, you can get the capabilities, you can get all the Yang files, you can get exact XPath as well. So you can extract some path XPath as well. Now what happens is when you have this config and you run, there's an API call that you run, all of this will be executed, and then all of this data will be stored locally, so that it's reusable, so you can reuse it in You can keep reusing it without connecting to devices each time. The one on the right, so this is basically the steps inside the code, basically the functions that are executed inside the code. I have detailed explanation for all of this inside the link below. But basically, in brief, what happens is we create the entities in the beginning, and then we start creating a relation between them. And then at the end, basically the last two steps are storing this to the GraphDB, to the Neo4j. So this is the second one. I don't know if the slide is small or you can see it. So here, so these are the ones that are explaining more in the yellow ones. So the one on the left, 1, 2, 3, here the order is a little bit important so you can understand the process. But on the top left one, number 1, this is more like the network model. And then basically you would have the node model. I just didn't put it here as well. But in this one, you have the link model under IETF network topology. You have the link model or link interface. Now, number 3, you basically start with creating the upper layer 1, which is the layer 3 unicast topology. And you see this is the parent. If you look at the parent, it's a little bit small, but you see the parent is the network. So this is using the model in number 1. So it's more like extending this model. Number 4 is same concept. So this is, I'm creating a new thing called ISS area. And now this is using the layer 3 unicast topology as a parent. So I use this as a parent and then extend it with more properties as well. So at this point, we have all the entities, the models that we need. So number 5 is actually the one to how to create the, the instance data. So all of this 1, 2, 3, 4 plus others are input for this model, for example, and from the other part, the configuration. So remember this. If I go back, this dash line in the middle, and this is the ISS area, for example, in this one. So we look at the configuration, we take all the configuration, we take the model, and then we have this mapping file, in this case, ISS area Python file. And then this one, we do all of this is a big file, so I didn't put the screenshot here, but you can have a look on the Git. But basically, what happens is we take basically the important ones of these properties, and we start assigning the data to it. So for example, network ID, how do you get the network ID? How do you get the router ID? How do you get the area ID in this example? So this is basically the logic is in this file. The relations is the one that we use to create basically relation at the end. And so here you see it's more like rule-defined ones. So you say, this is between ISS area and ISS process. So you can say, if the source is a network ID and the destination is network ID, then, create a relation between these ones and so on. So there are many relations. I only have here 2 to just demonstrate the point, but there are many others as well. Basically, when you have these configurations, next thing is to start run the code, and then it's the code is based on when you run the code, you have it's basically running on Flask, so basically there's a couple of APIs that you can call to execute. So there are like Discover Lab. Discover Lab is useful when you start. This will start connecting to devices, storing the configuration. The second one is where you want to generate a digital map. It's called Generate DM, but it's basically running all the steps that I showed in the previous slide. So, and then stores this at the end to the Neo4j if mentioned in the configuration file. There is also a network API call that you can, I'll show an example for this one and the next slide. but it runs on top of the Neo4j information. This is an example output with specific type of queries that we do in Neo4j. So in the left one, you see the layer 2 connectivity. And this is basically, for example, mapped from LLDB, for example, plus, yeah, just LLDB in this example, layer 2 connectivity. ISIS neighbors is mapped from the, all of these configuration models. So configuration plus state, thanks to know the neighbors for each, to find the neighbor for each interface, for example. So you would see the nodes, termination point, and links, and basically you see here that we have kind of a domain or a circle. Basically, they are all connected together. The one on the right, this is where I connect both of them together. So you can say this is more like supporting relations. I think they are in green. So these are supporting relations. So you can see the supporting for each ISIS node to the layer 2 node, ISIS link to the layer 2 link. So you can basically are able to traverse top to down or down to bottom or down to up. This is an example of the API response. So on the right here, you see the full one. So this is showing the network ID, all the supporting networks, and then inside you see the nodes. Here you see the nodes. For example, we named them like ISIS something. This is basically from the mapping file. Here we choose the
Sharif, please, as we are running out of time, please if you can conclude it to be fair with Italo. Yeah, please, thanks.
Yeah, next one is last slide, so I'll be quick. So yeah, so the right one is the full one. The left one is basically you can do a filter, so you can show me the nodes under this network ID, and I have example here on the link, the GitHub link. This is the last slide. So this is the one that what we are looking to have maybe next. So so one thing is we had the ISIS, so we wanted to prove this to work for OSPF as well, to see if there are any limitations or everything can be supported. So looking to have OSPF covered as well or implemented as well. The second one is we're looking at if we can do capacity planning example. So something that we can show, how we put planned capacity with failure models, for example, on top of this one. There are two others, which is the SRv6, and if we can connect the topology to other config module, we have all of this in mind, but likely the first two ones will be OSPF, capacity planning, and the topology to config modules. This is what we are currently looking at for IETF. And what I hope for people here is you can start using the code, start looking at it, and if you have, provide feedback, and if you have any problems, let me know. It's very good to have other people using it and see it actually helps people to hopefully create a multi-layer network.
Thank you very much, Sharif, for sharing this.
Thank you.
I think we can move. Italo, I think the floor is yours.
Thank you. I prepared just a few slides on following up the discussion we had. Can you hear me, by the way? Can you hear me well?
Yes.
Okay,
yes.
good. Okay. So it's just following up a bit some of the slides that we discussed in the last interim meeting on how we can apply the T topology for the digital map use cases. Next slide, please.
You can control the slides.
Oh,
yourself.
I can control the slides. Sorry.
Yeah.
Okay. Thank you. Okay. Yeah. Okay. So we had raised already in previous meeting and released some comments about the fact that the T topology can be used to support a digital map use case. We had some detailed presentation last time, but we didn't finish. But for this reason, in the backup here, you can go back and see all the slides. I'm wondering, we had some discussion also during the IETF 120 whether submitting to NMOP an applicability in the, interim draft may help to clarify this case. But I have, after I read the draft, I'm a little bit confused about what is a digital map compared to T topology. That's why I raised the question before. Maybe we need to have some discussion on whether the digital map is covering just a subset of the use cases, which basically can be addressed by a profile of the topology. But if I look about some description about the topology to support the full life cycle, TE is part of the full life cycle, but there is even more than TE in a full life cycle. So if you want to support a full life cycle, your topology model should include the T topology model plus a lot of additional information, so some of which have not yet been defined. Also, when I look at discussion on the POC, I wonder whether we are talking about only layer 2 or layer 3 without T, or whether the target of digital map is to describe any multi-layer network, which includes, for example, WDM, OTN, and MPLS-TE, because for these three type of topology, the AT topology is required because these three topologies are defined as augmentation of the T topology. So I think, but I think one of the major blocking points is really to understand what is going to be a digital map. I think this meeting has made a step forward, and maybe not sure by the next IETF, but definitely before 2022, we may be able to come with some more details in an applicability statement draft. And there was some question. Oh my God, they are not that nice. I think you can see better in the PDF, in the PowerPoint draft version of the slide. But okay, there are some, I've been asking about some POC or existing reference implementations. I have a lot of private information, which unfortunately I'm not sure I can share, but there are at least 2 events where the T topology was tested in multi-vendor environments and which are public. So the first event is two plug tests organized by ETSI for the microwave network. So the environment was a multi-domain microwave network, which a microwave controller for each domain, and where people were implementing the T topology, the microwave topology, which just was published as an RFC just yesterday, and some Ethernet topology, extension to the topology for the Ethernet layer, and people were using that. We don't need, and we did some profile, of course, of the T topology, because, for example, microwave is not a T layer, it's not switching at all, but there are a lot of information in T topology which were useful in this scenario. 2 specific information were the multi-domain topology discovery, how to discover which Ethernet link at the edge of a macro domain is connected with which Ethernet interface on another microwave domain, which is the interdomain topology discovery requirements, which is supported by the T topology. And the second case is the multi-layer navigation. The switching layer in the microwave network is Ethernet. So how can you navigate from an Ethernet link to the corresponding microwave link supporting it? And we benefited from the interlayer description of the T topology. So just a very simple T topology profile was defined and reused in this plug test. What we did at the time was basically I did manually pruning the oblique YAN tree from the topology, and people knew exactly what needed to be implemented and checked only that the leaf required was implemented. People were able to implement more but not less on the profile being required. And there were 2 events that were all of them very successful. Let me express a bit of frustration of myself, because I'm trying to promote the usage of IETF YAN models everywhere, in every forum I'm participating in, and I found the most difficult forum to promote IETF YAN models being the IETF itself. So I had a long discussion, but just not as long as here, but okay, that's in a couple of weeks we closed and everybody agreed that the profile was solving the problem in a sufficient way, and it was implemented by multiple vendors in an interoperable way. The next event, also this one, sorry, it's a multi-domain OTN networks where we had two domains, one from Huawei and one from Nokia. And we have a supercontroller from Huawei being able to create a service to do multi-domain OTN topology discovery and service setup across two vendors OTN networks. This was organized by China Mobile in September 29 and attended by Huawei and Nokia Shanghai Bell vendors. And there is an IEEE paper that describes all the extensive use cases that were tested at that time. Okay, next slide. It's okay. So, okay, about the implementation, we had a lot of discussion on this, and I got some concern about the complexity of the T-topology because there are use cases in some, maybe not use cases, maybe not in all, but in many use cases, you don't need a whole to implement a whole topology model, but just a subset of the whole model. And being able to defining the profile of the system model looks to me a more generic issue than just profiling T-topology for digital map. It's just one of the possible cases where being able to profile a YAM model, because otherwise what I see is going to be an explosion of YAM models, because you can always find a use case where the existing YAM models has one attribute more than what you need. And that will mean that for every specific use case, we are going to create a proliferation YAM model that addresses overlapping common cases. It would be better to have the possibility to profile, and we have already some implementations, but we don't have tools. So it's very hard if you want to scale on more use cases to have to implement profiles, and so basically we think that the best idea will be to go to NetMOP working group, submit a problem statement, which we may start with a problem statement describing the issue that we have on the need to profile existing YAM models, and see if we can come back with some standardized mechanism that allows to define ad hoc or even standard profiles of existing YAM models, such that when you have a use case that can be addressed by profiling existing YAM model, we do not need to create yet another YAM model which is going to be incompatible with the existing one, but we can simply standardize what is the minimum subset of attributes of the existing YAM model that are required to address the specific use case. Another set of concern was about the fact that the information which is can be retrieved by the topology model is not formatted in the way that is suitable or convenient for digital map applications. I remember the discussion about, for example, the bidirectional link. You have the information that the link is bidirectional because you have two unidirectional links between two TPs, but there is no explicit information that is telling you what is that the link is bidirectional. Another case I know is, for example, there is no explicit information in the current models that tells you what are the connections over a given link, but you can read the database, do a query on the database, and get all the information that you want. So the question is whether we need to create a sort of application-specific views of the content of an existing YAM data store. What do we do? Are we going to define a standardized, are we going to define a proliferation of YAM models which are providing exactly the same set of information, just in a different format because of different application needs? Or do we need to standardize something which allows to create a view for of an existing data store? So our suggestion is that is quite generic. It's not only T-topology for digital map. There are other use cases where the information is already defined in standard YAM model, but is not formatted in the way you are expecting it. So the plan, maybe we can do another problem statement ID to start a discussion in that working group to see if we can do a way to get a view, to create application-specific view from YAM data stores which are using standard YAM data models, rather than having a proliferation of YAM data models which provide exactly the same information in different structure.
Italo, please, if you can conclude.
Yep, that's all. Okay. About the hackathon, there was a proposal for the hackathon. We are not sure. I still cannot guarantee that we'll be able to do an hackathon, but we can have some hackathon and there are two use cases in the slides. One is bidirectional, and one is the multi-layer navigation. But I don't have yet secured the resources for that. So we will try to do that.
Yeah, so thank you, Italo. That's really natural, I would say, transition to the next slide when we tried with the, I would say, with Benoit to summarize some of the point that was, I would say, mentioned and raised during the meeting, and one of them is basically we didn't see any detail about the hackathon, the discussion or the plans for both the what Sharif presented and also what you have presented. So it would be really good if you can have, I would say, this kind of discussion and some kind of coordination during the coming weeks to see if there is something that can be planned and organized for the next IETF meeting. For the at least the first two slots, the one about the terminology. So we noted that there is open discussion. We see that there is still camp right now in the working group, whether we really need to have a new a formal definition for the topology, and or whether we need to define at the level of the IETF, or simply restricting it to I would say the usage of digital map. And also to clarify the link between the network topology and the topology itself. So we hope that the discussion will be happening on the mailing list on this point. I trust that Olga will be driving this to try to seek for more feedback and then hopefully to converge on how we can solve this at least by and propose a plan by the next IETF meeting. And then there's some of the point that was discussed during the recurrence slot. The key one was about whether the dynamic information should be part of the core digital map or should be excluded. So far, there is a requirement which says that this is out of scope, but the feedback I'm hearing, and we are hearing also with Benoit from the working group, is that this is not, I would say, that clear. I see that Italo, for example, is more on having this kind of dynamic information on digital map. So yeah, so more feedback on the mailing list are really good to happen there. There are some other redundant requirements, so some cleanup is needed, but this is just 0.0 version, and we expect that the document will be, I would say, enhanced by more reviews and more input from you as well. That's at least the main point that we summarize on our side. Benoit, I don't know if you have more to mention here.
No, this is perfect. Thank you.
So thank you. Unless there is any someone who want to make additional comments, I think that we can adjourn for today. And thank you all again for the positive spirit and the positive collaboration in the discussions. Thank you all.
Thank you.
Thanks. Bye.